Welcome learners to Black Slides Online Tuition. This is a platform where you can come freely to learn different science subjects such as physics, chemistry, biology, and mathematics, and other sciences. It is also on this platform that sometimes you will be able to access lessons in computer studies or ICT, which is information communications technology. Alright, so feel free, very free, to interact with the material in this forum. And in case you have questions, you are welcome to ask. There are two ways to do so. You can ask by simply commenting in the comment section on this channel, or you can send us a text on this number. We'll be very quick to attend to you. Once again, my name is Mr. Pochilola. Don't forget to subscribe to the channel so that each time we upload a new lesson in video format, you should be able to get a pop-up, like to be informed of a new video. So welcome to today's lesson. This is a topic in the Msce physics, which is called digital electronics. Digital electronics. By just hearing the word digital, many things are ticking in your mind. Okay, we are in a digital world. That's what everyone is saying now. Okay, where everything is digital. Sorry, it's repeating the word digital in this case. Like if you're using a phone to access this lesson alone, that's utilizing digital technology. Okay, if you're utilizing a phone, or you're watching a video on the TV, plasma television, that's digital technology at work. Okay, using a calculator, scientific calculator, and any other digital gadget. All right, it's an application or use of digital electronics, a field in physics which is called digital electronics. All right, so we are going to look at the principle on which digital devices work. Okay, the principle on which digital devices work in this topic. My name once again is Mr. Pochilola. Do not hesitate to contact us to ask questions based on what you have learned. In case you need some clarifications, don't hesitate to come back to us. You can leave your question in the comment section on this channel, or you can text us directly to this number shown here. Alright, so don't forget to subscribe to the channel so that each time a lesson is uploaded, you should be the first one to be notified. Alright, thank you very much. So stay on, watch the video up to the end. This happens to be lesson number 1, the first lesson of the topic digital electronics. This topic comes in Form 4 of Msce syllabus. But those who are doing other syllabi like Cambridge syllabus can also benefit from the same by noting down that which is relevant to their syllabus. All right, that's great. All right, so in order for you to understand the topic, let's begin by looking at a very useful theory, which is very key to your understanding of the topic. That's the theory called energy band theory. Energy band theory. All right. So the theory is just an assumption. It is an assumption that when two or more atoms are brought closer to each other by whatever means, the energy levels is split into smaller energy levels which are called bands. So the energy band theory is a statement which is just based on assumption. Okay, it's assuming that if we bring any two atoms closer to each other, close enough, their interaction will lead to the formation of smaller energy levels which are called bands. All right, just a quick reminder, you know that an atom or atoms are smallest particles of matter. Okay, so think about those particles getting really close to each other. All right, their energy levels are going to get split, to be divided up. Okay, they'll be divided up to form tiny or smaller energy levels. So those smaller energy levels are called bands. All right, you would recall that energy levels are sometimes called shells. All right, they're sometimes called shells. In some cases, they're called orbitals. So the orbitals of the atoms that come closer to each other are going to split up into smaller energy levels which are called bands. So what are bands? Once again, bands are simply smaller energy levels. Where do they come from? They come from the splitting of larger energy levels which are from the two atoms that are brought closer to each other. So once again, the energy level, the energy band theory is simply an assumption that when two or more atoms are brought closer to each other, the energy levels split into smaller energy levels known as bands. So technically in this topic there are two types of bands. In this topic, in digital electronics, there are two types of bands. All right, we have what are called valence band. Take note, valency, not valence with a y at the end. No, this one should be valency with NCE, not valence with NCY. Unfortunately, both valency and valence exist in science, in chemistry, to be specific. All right, you do recall in chemistry that valency is the number of electrons in the outermost shells of an atom. All right, so valence band therefore is a type of band which contains the valence electrons. What are valence electrons? Valence electrons are the electrons that are found in the outermost shell of an atom. All right. So where the valence electrons are found is called valence band. So this is just the location of outermost electrons. If I'm to break down this so that you relate to your chemistry knowledge. Other than valence band, we have conduction band. All right, so the conduction band is a band that contains conduction electrons. Conduction electrons are also called free electrons. They are the electrons that are responsible for conduction of materials. Okay, like you talk of metals. Why metals conduct electricity is because they contain conduction electrons, which are also called free electrons. So between these two bands, the valence band and the conduction band, there is a gap. There is a gap or a separation. A gap is also called a separation. So a separation or a gap exists between these two bands. What are we saying? We are saying that between the valence band and the conduction band, there is a gap. All right, there's a gap or there's a separation. So this gap is known as forbidden energy gap. All right, it's called forbidden energy gap, or simply the forbidden gap. Okay, you do recall forbidden means not allowed. Okay, why such a gap is called forbidden gap is because electrons are not allowed to be found there. Okay, electrons are not allowed to be found there. So electrons can either be found in the conduction band, like free electrons, or they can be found in the valence band, So where valence electrons are found is called valence band, and where conduction electrons are found is called conduction band. Between the two, there's a gap there which is called forbidden gap. Forbidden means not allowed, so electrons are not allowed to be found there. So based on the conductivity of materials can be classified into three. We have what are called insulators, we have what are called semiconductors, and then we have conductors. All right, so this classification is based on whether a material is a good conductor of electricity or it is not a good conductor of electricity. We are going to discuss these three types of materials in this lesson. All right, so what are insulators? Okay, insulators are simply materials which are generally poor conductors of electricity and heat. All right, so materials that are generally poor conductors of electricity and heat are called insulators. Okay, they are also considered to be bad conductors of electricity and heat. Okay, by bad conductors or poor conductors, we mean they hardly allow any current to flow through them. Right? Okay, so such materials are called insulators. They are not good conductors of electricity. They cannot allow any current to flow through them. In other words, they allow zero current to flow through them. All right, so they will ask you in an exam, especially in paper 1 of your physics. I'm referring to the Msce paper 1 physics. Explain why, or give a reason why insulators do not conduct electricity. All right, so the reason why insulators don't conduct electricity is because they have a very large forbidden gap between an empty conduction band and a completely filled valence band. Referring to this diagram here, you can see this material, this diagram represents a material which is an insulator. Okay, it has two regions. This region, which is called the valence band, which is completely filled with electrons. And then up there, you have the empty conduction band. So for the time being, the conduction band is completely empty. In other words, there are no free electrons there. Okay, while in the valence band, there are a lot of electrons. the valence band is completely filled with electrons. Now, like we said, between the empty conduction band and the valence band, there is a gap which is called forbidden gap. So insulators do not conduct electricity because this gap, the forbidden gap, is too large for electrons to jump from the valence band to the conduction band. Remember that for a material to conduct electricity, current must exist through it, must flow through it. All right, and the flow of current, or what you call current, constitutes the flow of electrons. All right, so the electrons are not so free to move from the valence band to the empty conduction band. Because of that, insulators do not conduct electricity. So why insulators don't conduct electricity is entirely because their forbidden gap is too large. So electrons cannot jump from the valence band through the forbidden gap to the empty conduction band. This gap is too wide. Okay, so they will ask you explain why insulators do not conduct electricity. It's because they have very large forbidden gap between an empty conduction band and a completely filled valence band. So already we have a mark there. Usually the reason why insulators don't conduct electricity at all, simple reason, they have a very wide, very large forbidden gap. The forbidden gap is going to disallow the electrons to jump from the valence band to the empty conduction band. All right, so this could be a 2 marks question. Why insulators don't conduct electricity? So you say they have very large forbidden gap. That alone is 1 mark. Between the conduction band and the valence band, that's another mark. Okay, they have a large forbidden gap between the conduction band and valence band. That's 2 marks. Okay, sometimes you'll be required to mention just some examples of insulators. So materials such as wood, especially dry wood, such as timber, for example, or firewood, or any other material that is made of wood is an insulator. Plastics such as plastic bottles, plastic shoes, plastic cups, plastic plates, all those are insulators. If you connect them in a circuit, they will not allow electric current to flow through them. Therefore, they are called insulators. Others are rubber. Rubber is also an example of insulators. So if you connect the rubber in a circuit, it will not allow any current to flow through it. Therefore, it's an insulator. So why don't these materials conduct electricity? It's because of the very large forbidden gap between the valence band and the conduction band. I hope we are together there. In case you have questions, don't hesitate to drop your question in the comment section below, or you can contact us directly using the number that is given on the home screen, of this lesson. Once again, my name is Mr. Pochilola, and I'm your teacher on Black Slides, together with other teachers representing Black Slides elsewhere in Africa. Right, so having looked at the insulators, let us look at another type of materials which are called semiconductors. semiconductors. All right, so we looked at the insulators before, and we said that insulators are materials which do not conduct electricity and heat. All right, so heat and electricity cannot flow through such materials. And we also looked at why. The reason is their conduction band, rather their forbidden gap, is very large, such that electrons cannot freely move from the valence band, where there are lots of electrons, to the conduction band, where there are few or none. All right, so what are semiconductors? Define semiconductors. Definition: semiconductors are considered to be materials whose electrical conductivity is midway between conductors and insulators. All right, so materials which are partially good conductors and partially bad conductors are called semiconductors. Okay, they are not too poor to conduct electricity. They are also not too good to conduct electricity. They are just in the middle. All right, so they allow only partial current to flow through them. We call them semiconductors. In fact, the word sem means halfway or midway. Okay, sem. Everywhere you hear semi, the word semi attached to something else, it means there is simply midway behavior of doing something. Okay, so here we are looking at semiconductors. They are materials whose electrical conductivity is halfway between conductors and insulators. Okay, the common examples of semiconductors are silicon and germanium. Notice that these are elements of the periodic table belonging to group number 4 of the periodic table. If you go to your periodic table, you find silicon, and below silicon there's germanium there. Okay, so these are the two examples, common examples of semiconductors. In case they ask you to state any one example of semiconductors, you can mention silicon or you can mention germanium, one of the two. All right, so both of them are semiconductors. Now, in semiconductors, this forbidden gap is smaller, okay, compared to insulators. We said that in insulators, the forbidden gap is just very wide, which is why insulators don't conduct electricity. But in semiconductors, the forbidden gap is smaller compared to that of insulators. So because the forbidden gap is smaller, electrons can easily jump from the valence band to the conduction band. That's why semiconductors who allow some current to flow through them. Why? Because this gap, the forbidden gap, is smaller compared to that of insulators. The distance between the valence band and the conduction band is not as wide as it is with insulators. This is very small, which makes it easier for electrons to jump from the valence band through a small forbidden gap to the conduction band. Now, this is what happens. Let's suppose that sorry about that. All right, let's suppose that we have an electron here. An electron is somewhere there. All right, and it has enough energy to jump from this point to this point here. All right, then from this point to another point there, and then jump through the gap to the conduction band. All right, now the original position where the electron was located, here where I'm pointing, all right, when immediately the electron leaves that point becomes positively charged. Listen carefully. We are saying, let's suppose that the electron is here and then it has jumped from there to another point, and from here to another point, and then finally up there. The original place where the electron was before it moved is called a hole, and it is a positive charge. It is not a proton, it is just positive particle similar to a proton. So the original position now changes its name, or gets its name, which is called hole. So a hole is formed when an electron has moved from its original position to another position. All right, so how do you increase the conductivity of a semiconductor? Okay, they'll ask you, how can you enhance the conductivity of semiconductors? For example, silicon. How can you improve its conductivity? How can you improve the conductivity of germanium? All right. So electrical conductivity of semiconductors, which are pure, and they're also called intrinsic semiconductors, increases with increase in temperature. So in order to increase their conductivity or to improve their conductivity, the conductivity of semiconductors, simply apply some heat to them. What the heat does is that when the temperature of semiconductors is increased, more electrons in the valence band gain enough kinetic energy to enable them to jump over the forbidden gap into the conduction band, hence enhancing or increasing conductivity. All right, so we are saying, let's suppose an electron is heated there. All right, so electrons, once heated, will gain kinetic energy. Remember that heat causes kinetic energy of particles to increase. All right, so the electron gains kinetic energy, causing it to jump from one point to another, and then the energy is large enough to cause the electron to jump to the conduction band. All right, so as many electrons as possible, when heated, will gain kinetic energy and jump to the conduction band. So we are saying, how do we increase the conductivity of semiconductors? By simply heating the material. So electrical conductivity of semiconductors increases with increase in temperature. Why? Because when the temperature of the semiconductor is increased, more electrons in the valence band gain enough kinetic energy to enable them to jump over the forbidden gap into the conduction band, thereby increasing their conductivity. So they can ask you, state one way of increasing conductivity of semiconductors by simply increasing their temperatures, because temperature causes the electrons to gain kinetic energy such that the energy is large enough to cause them to jump through the forbidden gap to the valence band, conduction band, thereby enabling them to conduct. Notice that this cannot be done with the insulators. Okay, you cannot increase the conductivity of insulators by raising their temperature. Let's say plastic paper. You cannot increase the conductivity of plastic paper by heating it, because what is going to happen to it is that the paper is simply going to be burnt. It is going to melt and be burnt. Okay, so before it conducts at all, the paper will simply burn and be destroyed. Okay, but with semiconductors, it is possible to increase their conductivity because they don't burn when the temperature is increased. Instead, the electrons will simply gain enough kinetic energy which will enable them to jump through the small forbidden gap to the conduction band. I hope we are together there, but in case you are not comfortable, you are lost, you are left behind, don't hesitate to talk to us, either to leave a comment in the comment section on this platform, or simply send us a text message through the number, using the number that was given to you. My name, once again, is Mr. Pochilola, your teacher on this forum, and expecting to hear from you. And please inform your friends that it is possible to learn on this forum entirely for free and without paying any dime or any fees. All you have to do is subscribe to the channel so that you don't miss on any videos as they come. My name, once again, is Mr. Pochilola. Alright, so enough has been said about semiconductors. So far so good. We've looked at two types of materials based on their ability to conduct electricity. Namely, we've looked at insulators, and we said that insulators do not allow electric current to flow through them. Why? Because they have a very large forbidden gap. So electrons cannot jump from the valence band to the conduction band through the very large forbidden gap. Unlike semiconductors whose electrical conductivity is halfway through or between conductors and insulators, their forbidden gap is smaller, which makes it easier for them to jump from the valence band. It makes it easier for the electrons to jump from the valence band to the conduction band. Hence, they conduct electricity. And we have also seen so far that the electrical conductivity of semiconductors can be enhanced, can be increased by simply raising their temperatures. What does the temperature do? The temperature simply increases the kinetic energy of the electrons so that as many electrons as possible gain kinetic energy and jump through the forbidden gap, which is smaller, and they get to the conduction band where they're free to conduct. Remember that for a material to conduct electricity, I should have said this before, for any material to conduct electricity, there should always be electrons in the conduction band. In the absence of electrons, some electrons in the conduction band, such a material is considered to be an insulator. All right, now let's look at our last class of materials, which is called the conductors. So I mentioned on the onset that there are three types of materials based on conductivity, namely insulators, semiconductors, and conductors. Right, so what are conductors? Okay, what are conductors? What are conductors? So let's define conductors. Conductors, as the name suggests, is a term used to describe materials which conduct electricity and heat at all times. So think about metals, metals like aluminum, copper, zinc, silver, mercury. Think about all metals belong to this group of conductors, materials known as conductors. All right, so we are saying define conductors. These are materials which conduct electricity and heat at all times. All right, so in conductors, the valence band and the conduction band overlap such that electrons move freely from partially filled valence band to the conduction band. All right, so we are saying that between the conduction band and the valence band, it's like there is no forbidden gap. Okay, so these two bands simply overlap, they join together without any separation. There's no gap to separate the valence band and the valence band and the conduction band. So since the forbidden gap is not there, all right, okay, electrons can easily cross. Electrons can easily cross from valence band to conduction band. Therefore, electrons, rather conductors, conduct electricity and heat. All right, let's suppose you heat this material. Okay, all right, so the electrons, rather, suppose you connect this in a circuit, right? So the electrons in the valence band can easily move to the conduction band without being interfered with by any gap. There's no gap between the valence band and the conduction band, which makes it easy for such materials, for metals, to conduct electricity. So they will ask you, explain why copper metal conducts electricity much easily. Okay, so you're saying it's because in conductors the valence band and the conduction band overlap such that electrons move freely from partially filled valence band to the conduction band. 2 marks. Explain why conductors conduct electricity. All right, it's because there's no separation, there's no gap between valence band and conduction band, which makes it easier for electrons to simply cross from the valence band, move from the valence band freely to the conduction band. Hence, conductors conduct. So it needs to be noted that electrical conductivity of conductors will decrease as temperature increases. Okay, so if you increase the temperature of a metal, its conductivity is going to decrease. Why? Okay, it's because when the temperature of conductor is increased, the vibration of its atoms or particles increases, and this interferes with flow of electrons. Remember, instead of having particles move, it is the electrons that move to the conduction band from valence band. Okay, but when you heat the conductor, the metal, the particles in it will gain kinetic energy, and that will cause the particles to vibrate about fixed positions. So those vibrations will actually interfere with the movement of electrons from the valence band to the conduction band. Therefore, electrical conductivity will decrease when temperature decreases. So we are saying electrical conductivity of conductors decreases as temperature increases. Why? It's because temperature of conductors causes vibrations of particles, mainly atoms. So those vibrations of atoms are going to interfere with the flow of electrons. You can consider this in terms of increase in resistance. Remember that as the temperature increases, the resistance of the material is also going to increase. Okay, so remember again that the resistance is simply an opposition to the flow of electrons. So the higher the temperature, the higher will be the resistance. Therefore, few electrons will jump from valence band to conduction band. Therefore, the conductivity is going to decrease. So far so good. We've looked at the 3 types of materials based on their conductivities. Namely, we've looked at insulators, which we said that insulators are materials which do not conduct electricity, and they do not conduct electricity simply because there is a very wide gap, large gap known as the forbidden gap between the valence band and the conduction band. So that wide gap prevents insulators from prevents electrons from jumping from the valence band to the conduction band. Therefore, insulators don't conduct. Even if you heat the insulators, instead of enabling them to conduct electricity or enabling electrons to jump from valence band to conduction band, what's going to happen is that the material will just get burned. Alright, it will burn before it has conducted any electrons at all. Alright, on the other hand, we've looked at the semiconductors, and we said these are materials which lie midway between, whose conductivity lies between that of conductors and the insulators. So semiconductors are capable of allowing some of their electrons to move from valence band to conduction band through a smaller forbidden gap, because the forbidden gap between valence band and conduction band in semiconductors is very small. Electrons can easily jump through that small gap to the conduction band. Therefore, they conduct. And semiconductors can have their conductivity improved or enhanced by simply raising the temperature of the material. What the temperature does is that when the temperature increases, electrons are going to gain kinetic energy. Remember that kinetic energy is energy of movement. So particles move from the valence band to the conduction band when the material is heated, and that improves the conductivity of the material. Lastly, we've looked at conductors as materials which conduct electricity and heat, and that they are able to conduct without necessarily heating them, because there is no gap, there's no separation between valence band and conduction band. Therefore, electrons can easily move from valence band to conduction band without having to be interfered with. And again, notice that you cannot increase the conductivity of conductors or metals by heating, because what the heat will do is simply to cause the atoms of the metal to vibrate. So those vibrations are going to interfere with the flow of electrons. In other words, there's going to be an increase in electrical resistance. Remember that electrical resistance increases with increase in temperature. Therefore, conductivity is going to decrease when you heat the metals. Alright, for now, I would like us to stop here. I must appreciate that you were around, and we shared this lesson, our first lesson in digital electronics. So we meet again in lesson number 2. I urge you to be there, inform your friends, share the video, the link, so that as many people as possible, especially those who are preparing for their Msce exams, they can join, they can come and subscribe to the channel, and so prepare them for the coming exam. My name once again is Mr. Pochilola, and I'm expecting to see you next time. Bye bye for now.